walking towards the bus stop to catch the school bus. Tony's school is 16 kilometers away from his house. And the school bus picks him up from the bus stop, which is 1 kilometer away from his house. Tony takes an hour to reach school this way. However, while returning back from school, the bus drops him at his colony gate, barely 100 meters away from his house. So, he reaches home in nearly 35 minutes. Tony is wondering what his speed is, and what the speed of the school bus is. Tony recalls that he can find his speed and the speed of the bus by setting up linear equations involving two variables. So, Tony assumes the speed of the bus to be x kilometer per hour and his speed to be y kilometer per hour. Now, Tony covers 15 kilometers by bus at the speed of x kilometer per hour and 1 kilometer by foot at the speed of y kilometer per hour. Also, Tony took 1 hour for the entire journey. Now, recall that speed, distance and time are related by the formula for speed, which is equal to distance upon time. Substituting the values in this formula, Tony got his first equation. Now, while coming back, Tony travels 100 meters by foot at the speed of y kilometer per hour and 15.9 kilometers by bus. Tony took 35 minutes to reach home. Using the formula relating speed, distance and time, Tony got his second equation. But the equations Tony obtained have variables x and y in the denominator. So the equations are not the usual pair of linear equations. So Tony is confused as to how to solve them. Can we help Tony solve these equations and find out his speed and the speed of his school bus? Let's find out. Look at the pairs of equations shown here. Are these equations pairs of linear equations in two variables? Well, these equations are not in the form ax plus by plus c equal to 0. So, they are not linear. But they can be reduced to linear equations by suitable substitutions. Let's understand how to reduce such equations to linear equations. For the first pair of equations, we can see that they can be reduced to linear form by taking 1 by x to be equal to p and 1 by y to be equal to q. So, the pair of linear equations in two variables p and q are 2p plus q equal to 5 and 3p plus 2q equal to 8. Similarly, the second pair of equations can be reduced to linear form by considering 1 over x minus 1 to be equal to u and 1 over y minus 2 to be equal to v. Then, the pair of equations in variables u and v are 5u plus v equal to 2 and 6u minus 3v equal to 1. We can use any of the three algebraic methods, namely substitution, elimination, or cross multiplication to solve these pairs of equations. Let's now consider the first pair of linear equations. For convenience, number the equations as 1 and 2. Let's use the elimination method to solve the given pair of equations. To make the coefficient of q in both the equations the same, we multiply equation 1 by 2 to get equation 3. We subtract equation 2 from equation 3 to get p equal to 2. Next, we substitute the value of p in equation 1 to get q equal to 1. Wait, we're not done yet. Our original equations were in variable x and y and not p and q. So, we have to obtain the values of x and y. We know that 1 by x is equal to p and 1 by y is equal to q. Substitute the values of p and q to get the values of x and y respectively. So, x is equal to half and y is equal to 1. Now, moving on to the second pair of equations. For the sake of convenience, number the equations as equation 1 and 2. Since the coefficient of v is 1 in equation 1, let's use the substitution method to solve these equations. Equation 1 gives v equal to 2 minus 5u, which is our equation 3. Using equation 3 in equation 2, we get u equal to 1 by 3. Using the value of u equal to 1 by 3 in equation 3, we get v equal to 1 by 3 only. We know that 1 by x minus 1 is equal to u and 1 by y minus 2 is equal to v. We substitute the values of p and q to get the values of x and y, respectively. So, we get x equal to 4 and y equal to 5. Now, we can go back to Tony's problem and find out his speed and the speed of his school bus. The equations that Tony got can be reduced to linear equations by taking 1 upon x as p and 1 upon y as q. Equations 1 and 2 reduce to 15p plus q equals to 1, and 15.9p plus 0.1q equals 35 over 60. Notice that these are linear equations in variables p and q. Let's call them equations 3 and 4. We can use any of the three methods, that is substitution, elimination, or cross multiplication, to solve the pair of equations. However, for the sake of simplicity, let's use the elimination method. Let's multiply equation 3 by 0.1 in order to equate the coefficient of q in both the equations. Let's call it equation 5. Subtract equation 5 from equation 4 and simplify to get p approximately equal to 1 upon 30. Using the value of p in equation 3, we get q equal to 1 upon 2. Now the value of p is 1 upon x and that of q is 1 upon y. So x equals 30 km per hour and y equals 2 km per hour. So Tony travels at the speed of 2 km per hour and his school bus travels at the speed of nearly 30 km per hour. So now Tony knows his school bus travels almost 15 times faster than him.